Thanks for inviting me to speak. A lot of what I was going to speak has been covered already. So, I guess that makes my job a little bit easier. So I'll try and focus on, really focus on what's incremental to what has already been said. And I think there are a couple of themes that I think jump out that I think we can cover in the context of what's been shared already. With that, I'll just get started. I'll speak mainly from a storage point of view. The assumption is that storage can be charged with rooftop solar as much as it can be charged from the grid. It can be charged with diesel. So in this case, let's just assume that it'll be charged with rooftop solar or open access solar or some sort of renewable energy. Just a quick background on Fluence. So we are a company that's owned by Siemens and AES. They're both power sector majors. We've been doing battery storage for the last 12 years. The first project was commissioned in 2009 in Chile, which was a 15 megawatt project at a coal power plant. So far, we have deployed or have under deployment over 2,100 megawatts of storage projects. And storage is the only thing that Fluence does. We are not in the EV space or the battery manufacturing space or doing storage because we have inverters to sell. We are only in it for, what Dr. Babu said, integration of all these different components and turning it into a power resource that our customers can use in a predictable manner, in a safe manner, and over a long duration of time. Just want to point out, that we have a list of our customers on the right side of the screen. You can see some of these are some of the large, most reputed companies in the world. So many times in India, we think of storage as a science project. It's a mainstream power resource across the world. And we are talking of its deployment in gigawatts around the world. And that's especially true for the North American market. So what is storage? I'll just quickly go over it. Many people think of storage as just batteries. I would say, simply speaking, batteries is just half the story. You got the batteries, and then you got to integrate them with primarily environmental control systems, and which is controlling the temperature in which these batteries operate. And then you got to have some, I think Dr. Babu talked about it, some very stringent safety measures, fire safety being the most important of them. Without that, you are creating a lot of risk, with such a system. And then all of that has to be put inside an enclosure, and then the DC current coming out of the battery has to be converted to alternating current, and then eventually it has to be stepped up to the voltage you need, which is done with a transformer. So all of that comes together as a storage system. So someone like a Fluence would give you guarantee all the way up to the low voltage side of the transformer, if that's what our customers want. This is a project, I shared this picture earlier. So this is a project that we have developed in Delhi. It's in fact developed by Mitsubishi Corporation and AES, and it is located at a Tata Power substation. So Tata Power is part of the project as well. This is inside a building. So all the things that I talked about are inside this building. This is in Rohini. I'm based in Gurgaon. It's about an hour and a half from here, from where Tobias is based in Delhi, where he's normally based. It's about an hour, and it's a must-see for anyone who's more interested in or wanting to invest in or deploy battery storage at their facility. So this is inside a building. You can also deploy batteries inside containers. This is a project that we developed in San Diego. You can see there are these 40-foot containers, and all the equipment is inside these containers. This is in fact in a commercial industrial neighborhood. You can see a building at the back, which I think is a residential building. I'll have to confirm that with you, but it's it's not located in a typical setting where you see a power plant located. So I like to call it like the friendliest power sector neighbor you can have that makes no noise, has no air emissions, has no wastewater discharge. You can build it in a period as short as 6 months, which is the case with this project. So this is about 30 megawatts, 4 hours built in a period of 6 months in what's clearly an urban environment at a substation. And it's been operating there for over 3 years now. This is what's of particular interest to the subject matter for this discussion here. This is a product which is, this is where battery is stored inside these smaller enclosures. We call them cubes. And this is a specific commercial industrial solution that we have. It is, basically we call it Fluence Edge Stack. And you can see it's sitting at a building right now. And it takes the footprint as much as it would be for a diesel genset of a similar capacity. From a capacity point of view, these systems can be anywhere from 500 kW all the way up to 3 to 5 megawatts. From a duration point of view, these systems are anywhere from 1 hour to up to 4 hours. So we've done systems that are 5-6 hours as well, but what we like is that 1 to 4 hour sweet spot. The voltage can be what you want it to be. There's a voltage coming out of the inverters, but like I said, if you want a different voltage, you can always add a transformer to it to get that voltage. These could be air cooled, they could be liquid cooled. The system you're looking at is an air cooled system. I'm sorry. This is a liquid cooled system, and it is entirely software operated. Okay, just some more detail on the system. What you're looking at is the cube on the left. So this is the piece of equipment that has the batteries. It has all the safety components, and we have 6 levels of safety built into this product. And you can see on the right side you have the cubes with the batteries in them, and then you have the telco equipment, which is where all the telecommunication sits, because you have to ultimately talk to the batteries, you have to talk to the grid, you have to talk to all the other sources of generation that you may have, one of them being rooftop solar. And then you have the power conversion unit that, basically converting that power, and then you have the transformer, which is shown in this picture as well. The conditions for effectively combining battery storage with rooftop solar, I think that's the area of focus for today's call. Like I said, a lot of this has been covered already, but I will say that across the board, the batteries today do not make sense as a replacement for all kinds of diesel. I mean, there's all kinds of diesel being used across the country. I mean, Tobias put up some very interesting numbers, around 120 gigawatts of diesel gensets being used in India right now. You can't go and replace all of them with batteries. Not with how they're being used right now, those diesel engines, and where the price of battery is right now. But what I can tell you is that there are many instances, and if you can create a perfect storm of those instances, you will find that battery storage makes commercial sense even today. So I'll tell you what that perfect storm is. Each of these have been covered already. I just want to say that all of these combined creates that perfect storm. So what I'm saying is, if you find a case in this country, whether it's in the Delhi-Jaipur corridor, whether it's the Goa industrial corridor, whether it's in Gujarat industrial corridor, where you will find a combination of all of these is where you will find that battery storage is commercially viable right now. And I speak of commercial viability because we are a technology provider. My job here is to make sure that these projects see the light of day and they add value for our customers, and people want more of them. And in that process, you enable the energy transition that we so urgently need, not just at the utility level, but also at behind the meter commercial industrial level as well. So the first instance is diesel. So there you definitely need diesel, but like I said, the duration of the battery is ideally maybe 4 hours. There are people who use diesel for 8-10 hours a day, nonstop. So batteries will not be ideally suited in those instances. You're looking for instances where the power supply is is unreliable, so it's coming and going. In the sense, you're having like the kind of power outages that we have in where I live in Gurgaon. We have like 15 to 30-minute power outages, and then diesel takes over. I mean, those are the kind of power outages that are best suited to be replaced with battery storage. So I'll run through these fast. These have been covered. There are regulations on the use of diesel, primarily because of environmental concerns. There are companies that are looking to incorporate more RE because RE is turning out to be cheaper than grid power, definitely cheaper than diesel power. And then I think this has been addressed as well. So we are looking for instances where the customer has a peaky load. So what you're looking at here is the annual load duration curve. This is looking at load duration in 30-minute time slots. And you can see the peak load is about 12,000 kVA. But that peak load is reached for a very small number of time slots. So you're looking at 500 time slots in the whole year, 500 30-minute time slots in the whole year, where the peak load reaches the full 12,000 kVA. So that means about 250 hours a year, which is about 10 days in the whole year. When you are drawing the peak load for which you have your connection sized. Here is one more example of it. You can see that in this case, this particular customer has a peak load of 20 megawatts. However, that 20 megawatt peak load is hit only for 1 or 2 hours in a day, 2 hours in a day. So that's the other condition. Like I said, the perfect storm, and I'm telling you what those conditions are. Peak load, peaky load being one of the third or the fourth condition. And then the fifth condition and the sixth condition are the quality of power. And I think this has been talked about already. There are customers for whom quality of power is important. I mean, they have equipment such as robotics, they have variable speed drives, and if there is a outage, of course, it causes them loss of inventory, and it causes them costs them restart expenses. And even if it's not a full outage, but it's a voltage drop that was talked about earlier, it still leads to a batch loss, and it still leads to restart costs. So that's like the other conditions. So these are like the 6 conditions. If you find these at a particular location, we can deploy the edge stack solution in such conditions even today, and it will make a lot of sense. Okay, so how does it do it? I'll just quickly go over this. So the battery will sit in line. Like I said, battery is software operated, and it's sitting in line in your supply network. And as soon as there's a disturbance, and the disturbance could be an outage that lasts, say, up to 4 hours. It could be a disturbance that lasts a millisecond. Let's say it's a voltage drop. In each case, the battery would respond to that disturbance and smoothen out your flow, power flow for a duration of up to 4 hours. Right. So we have in fact recently developed a solution in Ireland where there's a lot of influx of RE, and the system operator there is allowing an incentive tariff for faster responding resources. So we have worked with the system operator and the developer to develop a megawatt scale grid connected storage solution that responds in 150 milliseconds, and that then qualifies under this program that is there in Ireland for these grid supporting power resources. Okay, and in this case, and this was also talked about earlier, here you can see that if your peak load of 20 megawatts is hit for just 1 or 2 hours a day, you can put, and your average load is, let's say, 12 megawatts, you can actually install an 8 megawatt battery of a duration of 2 hours. So the moment your peak load goes above 12 megawatts, the battery kicks in. And what you do is then you don't pay the fixed charge for having that connection at 20 megawatts. Right, so you will save the fixed charge for that 8 megawatts for the whole year. And what we've seen is, this fixed charge could be, anywhere from like, $6 to $10 per kilowatt per month. So if you just add up the benefits, you got the fixed cost reduction, you have energy arbitrage where you are replacing expensive diesel power with a cheaper RE, from your rooftop installation. And we talked about operational efficiency. So if you have, batch losses, if you have startup costs, etc., you can add all those benefits to the business case. And I think a few people have talked about a virtual power plant. We call that a future benefit, where owners are incented to connect flexible resources to the grid, and they're incented by the system operators. So we are seeing kind of the beginnings of that, with the real-time market that we have, with the ancillary rules that are being put in place. We will see, we are seeing the signs of those pieces of this, this future benefit coming together already. Lastly, I just want to talk about this one project that we have recently done. And this is very important because, bankability of these projects is very, very important. I was just reading a news article the other day that electric vehicles in India are running into an interest rate of 25. So basically, a EV loan to a customer who wants to drive away with an EV instead of an ICE engine is being charged an interest rate of 25% for that EV loan. And I know that there's a rebate from the government to offset that high interest cost. But at 25% interest, are you really talking about a bankable solution? I don't know if I want that kind of bankability where I'm paying 25% interest rates, right? So it is very important, that the technologies that you have are you are able to finance those, and a banker would have enough confidence in the technology on how it's going to operate now, how it's going to operate 2, 3, 4, 5 years down the road. It's not just important to have a commercial model that works. It's also important to give confidence to your investor and your lender that the technology will work as promised, right? So in this project, we have this is a 20 megawatt 1 hour battery storage system where the technology provider, which is Fluence, financing companies, and an ESCO have come together to offer storage services to a brewery in Finland. What does it do? I'll just kind of show you, what the structure looks like. So what does it do for, like I said, the technology provider, the ESCO, and the investor have come together, and they have installed battery storage. And what it has done for the C&I customer for the brewery is, number one, it has improved the quality of power for the C&I customer. That's one thing. The second thing that it has done is it has added a new revenue stream for the C&I customer. And then the third thing that it has done is the C&I customer is a big load, and they need basically they need spinning reserve, and having this 20 megawatt battery available, their need for the spinning reserve has gone down because the battery will respond in milliseconds to meet their power needs, right? So that is what it has done for the customer. For the grid is again dealing with, the Finnish grid is dealing with the influx of RE, and they want to get more flexible resources on the grid. So the grid operator is willing to incent or sign a PPA with someone who is putting that flexibility on the grid, which is connected to the grid, right? So that is what is in it for the grid. And those are the benefits that are being then shared between the ESCO, the investor, and the C&I customer. So this is, again, this is possible, like I said, we are a Siemens-owned company, and when we put a product out there, then other parties step up as well, wanting to participate in that project because they know that I'm getting a guarantee here on the way the system is going to perform for the foreseeable future. So, and that's a very important piece. So I just wanted to make that my last slide. I just thought it was something that's very new, and I thought I should let the team know about this. I will stop with that, Tobias. Thank you.